Hello, so in this video we're going to talk through the scalar or the dot product. Now notice that I say scalar product or dot product, they both mean the same thing. They're both talking about the same kind of ideas. It's just that scalar product, the reason why we call it that is because the answer results in a scalar or a number. The dot product, reason why we call it that, is because the way which we write it is with a dot down the two vectors. So here we've been asked to find the angle between these two vectors. So I've got u, which is 3, -8, and v, which is -9 and 2, and I've been asked to find the angle. Well, you remember that the formula which I can use here is the cosine of the angle between the two vectors should just be equal to the dot product of my two vectors divided by the product of the magnitudes. Now this is just literally the cosine rule but thought about in terms of vectors. So first of all, let's find each component. So let's first of all find u dot v, the dot product of u and v. That's nice and easy. I just simply multiply the corresponding elements together and then add them. So 3 times -9 added to -8 times 2. So if I work this out, well, 3 times -9, that's -27, and then -8 times 2, that's -16. So therefore, this should come out as -43. Okay, cool. So that's my dot product. Now I also need the magnitudes of each vector. So in order to do this, I just simply use Pythagoras. So magnitude of u is just going to be 3 squared plus -8 all squared, and then square rooted. So that's going to be 9 plus 64, so that's going to be square root of 9 plus 64. That's going to give me square root of 73, and I'm going to leave it at square root of 73 because I'm still working with it. Doesn't make sense to round and use a decimal at this stage. And then for v, same kind of idea. I'm going to take -9 all squared, add it to 2 squared, and then square root the entire thing. So that's going to be, it's going to be square root of 81 plus 4. That's going to be square root of 85. Okay, so square root of 85. And then all I need to do is just stick all of these components into my formula. So I can say then that the cosine of theta should be equal to, well, my u dot v I found as -43. So that's going to be on the numerator, divided by the product of my magnitude, so root 73 times by root 85. Okay, now just pause for a second. I know that this comes out as negative, so I know that my cosine of theta is coming out as a negative. Now just think, the portion on the graph between 0 and 180 degrees, which is negative, is between 90 and 180 degrees. Just think about the cosine graph. So therefore, I'm expecting an obtuse angle here. In other words, I'm expecting my value of theta, the angle between my two vectors, should be between 90 and 180 degrees. But let's check it out. So I'm just simply going to take the cosine inverse of all of this thing on my calculator. So if I stick that in, cosine inverse, which you can find on a calculator as shift and cos, if you've got a scientific calculator, and I'm going to do -43 divided by square root of 73 times square root of 85. So if I stick that in my calculator, I find it comes out as 123.1 degrees. So yeah, it's obtuse. Okay, so always use that little check there. If it comes out as positive, you're expecting an angle between 0 and 90 degrees. In other words, acute. If it comes out as 0, you are expecting a value of, you're expecting an angle of 90 degrees. They're perpendicular to each other. And if you're expecting an angle, or cosine of theta is negative, then you're expecting an obtuse angle. In other words, an angle between 90 and 180 degrees. Okay. So let's have a look at the next question then. The next question says, same kind of idea, here's two vectors, A, which is 6i plus 4j minus 2k, and B, which is 5i minus k, and find the angle between them. Well, you notice first of all that I've been given my two vectors in ijk notation. In other words, I'm thinking about the unit vectors in each of the horizontal, vertical, and forwards and backwards direction. So just think I is just one step to the right, J is just one step up, and K is just one step forward, and I'm just doing whatever multiples. So I'm doing 6 steps to the right, and then 4 steps up, and then 2 steps backwards in this case. So just when you're working with ijk notation, I find it's always easier to visualize in column notation. So a good tip I'd give you is always try and convert these into column vectors. It is fine to work with ijk, I can do it, but I just find it easier to visualize and make sure I can match up components properly if I've got it written as a column. So A, I should be able to write 6 for -2 if I wanted a column vector. And if I wanted to write B as a column vector, well, this is where I need to be careful because I have no J component. I have no sort of up and down components. Therefore, that's just 0. So in other words, my I component is 5, my j component is 0, and my k component is -1. Okay. Now again, I want to find the angle between the two vectors. So let's first of all find the dot product. So let's find the dot product of a and b. So therefore, I just need to do 6 times 5 plus 4 times 0 plus -2 times -1. Okay, so 6 times 5 is 30, 4 times 0 is 0, -2 times -1, that's +2, so therefore the dot product is 32. Okay, cool. So actually from the dot product alone, because I know that this is positive, I know that cosine of theta must also be positive, because obviously the magnitudes will always be positive by definition. So because I know that my dot product is positive, I'm expecting that the angle between these two vectors is acute. In other words, it's between 0 and 90 degrees. But let's check out what the exact angle is. Well, I've not quite finished with the pieces of the puzzle, so I need first of all, what is the length of A? So the length of A is just going to be 6 squared plus 4 squared plus -2 all squared, square rooted. Okay, so what's this equal to? Well, it's going to be equal to the square root of 36 plus 16 plus 4. Okay, so that's going to be equal to the square root of 56, or 2 root 14. Okay, and let's have a look at this. Sorry, square root of 54, I meant. And so let's have a look at this now. So let's have a look at the length of B, so the magnitude of B. So I'm just going to take the square root of 5 squared plus 0 squared plus -1 all squared. So okay, that's square root of 26. So now I'm in a position where I can actually stick this into my calculator. So cosine of theta should be equal to in this case, a dot b, okay, so that's 32, divided by the magnitude of a, which is 2 root 14, times by the magnitude of b, which in this case is root 26. So I'm just going to stick it straight in my calculator, just go cosine inverse first of all. So cosine inverse of my 32 over my 2 root 14 times by root 26. So I stick that in my calculator, I find it comes out as, lo and behold, an acute angle, as I was expecting, 33.0 degrees to one decimal place. By the way, good kind of rule of thumb here, if you're working with angles, it's always a good strategy to leave your angles to one decimal place unless you're told to otherwise. So unless you're told like explicitly 3 significant figures or 2 decimal places, just by default, if you have to give it as a decimal, then leave it to one decimal place and that should be fine.